Imagine a routine medical scan, only to discover that the majority of the space inside your skull is filled with dark fluid. You might expect someone with this condition to be severely disabled or even completely incapacitated. Yet the patient in question was walking, holding a job, and living an entirely normal life. This case challenges our most basic assumptions about the physical volume of tissue required to sustain human consciousness. The discovery began with an ordinary hospital visit. A man complained of mild leg weakness, prompting neurologists to review his history and order imaging. This is the patient's MRI scan. Enormous voids of cerebrospinal fluid fill the interior, right where healthy brain tissue should be. In these cross-sections, dark fluid pockets dominate, leaving only thin layers of gray matter at the edges of the skull. Seeing nearly the entire cranial cavity engulfed by fluid leaves medical professionals with an immediate question: how was biological survival occurring? The structural changes seen in the scans are the result of severe hydrocephalus. This diagram shows the internal ventricular system. In hydrocephalus, excessive cerebrospinal fluid accumulates inside these spaces, particularly the lateral and third ventricles in blue. As volume increases, outward internal pressure pushes the surrounding brain tissue closer to the rigid skull. While headlines often sensationalize this as a man with almost no brain, the imaging revealed the tissue had been compacted into a thin, high-density layer along the internal wall of the skull. The biological marvel is the physical durability of that tissue. It continued to function while enduring immense chronic pressure for years. If the physical architecture of the brain is flattened and deformed, how does the nervous system manage to execute complex daily tasks? The answer lies in neuroplasticity, the brain's ability to reorganize its physical structure and rewire connections. Time is critical. Because the fluid buildup progressed over decades, the brain had a long runway to incrementally transfer essential functions to new pathways. A sudden trauma or rapid fluid accumulation would cause catastrophic neurological failure. A slow timeline allows the system to continuously adapt to the changing internal environment. The brain functions as a dynamic network, bypassing points of structural collapse to maintain operation through active, ongoing adaptation. This specific patient provides researchers with an extreme natural stress test. It represents the outer boundaries of neuroplasticity ever recorded in clinical medicine. By studying how these extreme structural compromises operate, scientists can map exactly how far biological adaptation can go before failure. These maps reveal the scope of functional redundancy, the backup pathways and dormant capabilities existing quietly within our neural architecture, waiting for activation. The nervous system holds a massive, untapped capacity for functional compensation. Standard medical models are only just beginning to comprehend the depth of this resilience. Establishing how the tissue physically survived leads to much larger, uncomfortable questions for modern neuroscience. Despite a massive structural collapse within the cranial cavity, the individual's consciousness, personality, and intellect somehow remained entirely intact. If a person can hold a conversation and manage a family with a fraction of the typical brain volume, we have to ask what we truly know about the physical origins of thought. Despite all our advanced imaging and highly detailed biological mapping, the exact connection between physical tissue and human consciousness remains a profound mystery. Beneath the stark black and white scans and the complex medical terminology, a real human life anchors this case. This was a man going about his everyday routine, walking through his city, unaware he was carrying a remarkable medical anomaly. Human biology demonstrates a degree of adaptability that challenges current textbook definitions. This life stands as proof that the physical body is often stranger than fiction. To explore more scientific mysteries that challenge our understanding of the natural world, hit the subscribe button and join us for the next episode.